In this section, we will talk about descriptives and frequencies, and so we will analyze using the same data here. We will analyze pretty much most of the descriptive statistics analysis. So we do that by clicking on Analyze. Of course, this presupposes that you already have the data filled up and all that. So you have to click Descriptive Stat, and you will only use, I think, for the at least for the most the simplest of analysis, frequencies and descriptives. So for frequencies, you usually do that for your demographic profile, but you can also do that for the result of your surveys if you have a Likert scale. But it's still best just to use uh, you use this for demographic profile purposes. Just click move to the other side, and then don't forget to look at this. If you want all this, you can just put a tick mark. The central tendency alone matters, and you can have that skewness, kurtosis, standard deviation for this. But since we are only focusing on the frequencies for the demographic profile, can have just leave it unchecked. And for the chart, you may want to use whatever you want. Bar charts, bar chart histogram. Maybe we could use pie chart for this and show percentages. Okay, then when we check, when we click OK, then this will be the result in the output section of your SPSS. Where is it? It's not here. Oh, it's just took time to show. Right, so here we have the total respondent is 40, and all the variables have been inputted. Okay, for the profession, we have 20 and 20. You have here the frequency count, the percent, and the cumulative percent. You have valid percent because sometimes the result there happens that there are respondents who would not answer, so there would be missing values. That's why there's a valid percent here. Okay, for this there are 19 females, 21 males. Okay, and then for the age grouping, you have 3 groupings here. Here for the length of surveys, there are about 4. So the rule of thumb here, as I said, is that if you have 3 groupings like this, then there should be at least 15 per group. Okay, so if you have only 40 respondents and you have 3 groupings, this will be a little bit skewed in the sense that if you are going to compare, you will only have less than on the average 12 to 13 respondents per grouping, right? So in a case like this, you would be forced sometimes to reduce this further to just 2 groupings. Like you can just drop off the 41 to 50, and then you would just say 20 to 30, 16, 31 and above 24. If that works, well with you. If not, then there's no need to quarrel about that. Just use this grouping. Again, you will see some skewness here for the length of service, but if this is really the case in the population, then you have no choice but to follow it. So we have valid 1 to 2 years, we have 9, 3 to 4 years, 5 to 6 years, 9, 7 plus years, 17. As you can see, it's a bit skewed on the 7 plus years. So if I were if I were the one who created this, then I would have joined or included both the 1 to 2 years and 3 to 4 years in just one group. I would just say less than 4 years, so there will be 14 of them. And you still have a problem because the 5 to 6 years is only 9, while the 7+ years would be 17. So there may be a way to do it by focusing on the 7+ years and then trying to ask them, okay, maybe some of them were there already for more than 10 years, then maybe that's the cutoff. So again, rule of thumb, there should be enough data within each of the data points. So you cannot have like, for example, single and married. Single, 99% of the respondents are single, and only 1% married. That's not a good data. If you will insist on that, then your research would suffer in the sense that you would not have enough comparison of data, and then the result would always be not significant. But of course, the disclaimer is that what if that is really the phenomenon, that you have really more male than female, more single than married, and you don't have much choice but to follow that kind of sampling. Okay, so for the pie chart, we use, I think we chose pie chart, so this will be how it will look like. Maybe for some, it will still be best to use Excel in the charting. So it's okay if you want to do that. The thing with SPSS is that you can just copy it, or for my case, I usually use a print screen called Lightshot, so that I'll be able to convert this into like a picture or an image, so that when you put it in your research in a paper, you can easily resize it. Okay, so that's it. So for the next one that we will do is to analyze the descriptive. So analyze and then descriptive stat. I'll just adjust this so that you can see. Analyze and then descriptive statistics. You have frequencies. Now we go to descriptives, and this time we'll focus on the survey questions. Put everything there. The options, you will take everything that matters for you. For example, if you want to know kurtosis and skewness, then be okay. If you want to use variance, some people would take some because they may want to use it in the future. Some would also use standard error domain. Minimum and maximum is included. They are included because we want to know whether the minimum rating and the maximum rating for each question. Okay, when you continue, you will have this kind of data. Okay, so it says here n, so that you will know that nothing was lost or nothing is missing. You have the minimum stat of 1, the highest is 4. If you add them all, there's 132. This is the mean, 3.3. The standard deviation, the standard error of the mean would be 0.11983. Standard deviation is 757 or 0.758. Variance is just the square of it, 0.574. Skewness is negative. What does this mean? It means that the data is skewed to the left or skewed negatively. It means that the tail is on the negative side of the normal curve. It means if you have a value here that's negative, it means there are more positive scores, there are more higher scores than there are lower scores. Okay, kurtosis, again, this is how flat or how tall the normal distribution is. Okay, so that's it. Just focus on all this, and you can always do an analysis. This is very simple. Okay, now for some, they also use what we call the coefficient of variation. So what you do is first, okay, so that it can open in Excel, you can copy this and then paste it in Excel. Okay, so if I will paste it in Excel, so it will be like this, right? So if I want to do an analysis of the coefficient of variation, I'll just insert a row over here, coefficient of variation, okay, so or CV if you want. CV is just the standard deviation divided by the mean, and it is understood in terms of percentages, so this will be converted to percent. Okay, I click the top of the column and then I just click percent over there. Okay, so it is now in percent. What is this? What are these values for, and what do they mean? Usually, the normal range is around 15% to 25%. And what you want to do here is to look at the data we have that have very low coefficient of variation, like this one, 70%, 80%. I think this is the total, so you expect that really to have low coefficient of variation, because this means that, among others, that the respondents are pretty much in agreement on the rating that they have. So if the rating is low and the coefficient of variation is also low, that means that they really agree that the rating is low. On the other hand, if you have like this 38% variation, it only means that the standard deviation is high compared to the mean. So look at these questions: radiologic technologists or nurses with more working experience, something like that. So that question is the result of that question has a high disagreement among respondents. The standard deviation is high compared to the mean. The mean is low, so that means they are not in agreement. They disagree with the question, and also there is a high disagreement among their answers. So those are the things that you can do with descriptive stack.